Hello and welcome to the Electrical Engineering Laboratory. Have you ever thought of observing an electrical signal or watch how the voltage varies instantaneously like a graph in your textbook? The oscilloscope can do it for you. After watching this first video, you will be able to identify the basic controls of a cathode ray oscilloscope and observe a signal using the oscilloscope. Let's see how to make it. The oscilloscope is the device that we can use to observe the voltage waveform of a signal. In a typical waveform sketch, there are two axes: horizontal axis for time and vertical axis for voltage. In the oscilloscope screen, we can see those horizontal and vertical axes. We usually call them X and Y axis. When switched on, the screen shows an illuminated horizontal line, which means there is no signal connected. We call it the trace. We can adjust the brightness and focus of this trace. To make sure that the horizontal line represents the zero voltage level, we place the input selector switch to the ground position and observe the line. If the line is shifted from the horizontal axis, we can use the vertical position controller to bring it back. To observe the signal, we place the selector switch to DC input. If we are not concerned about DC voltage component, we can use the AC input method. Before making any measurement, make sure that the horizontal and vertical sensitivities are in their calibrated position. As you can see, there is a marking CAL in these control knobs. Now we connect a probe to the channel 1 of the oscilloscope. The tip of the probe should be carefully connected to the point where we need to observe the signal. As an initial test, we connect it to the signal generated by the oscilloscope itself. Here you can see the parameters of this signal: 1 kHz and 2 volt peak to peak. The screen now shows the waveform of that signal. It is always required to select the trigger source same as the input signal. To observe the waveform with a clear view, we can adjust the X and Y scale. Now we can make the measurements. You can see the vertical distance between two peaks is 4 divisions. From scale, we know that one division represents 0.5 volts. That means the peak-to-peak voltage is 2 volts. The horizontal length of one cycle is 5 divisions. The scale is 0.2 milliseconds per division. That means the time of one period of the waveform is 1 millisecond. When it is converted to frequency, it is 1 kHz. The two parameters we measured, frequency and peak-to-peak voltage, are similar to the parameters indicated on the oscilloscope. We have correctly observed the signal. Now we are ready to measure an unknown signal. Now we connect a signal to the oscilloscope. Now we can carry out the scale adjustments to make a convenient measurement. As you can see, 1 period is 5 division. A scale is 0.1 millisecond per division. That means 1 period is 0.5 milliseconds, which is equivalent to 2 kHz. The peak-to-peak distance is 4 division. Scale is 1 volt per division. That means peak-to-peak voltage is 4 volts. We have successfully measured the signal. In this video clip, we have learned how to prepare the oscilloscope for an observation and how to measure the parameters of an waveform. Please join us with the next video.